Namaskar, I am Dr. Aarti Chaudhary, Assistant Professor in the Department of Ancient Indian History, Culture and Archaeology at Vasant Kanya Mahavidyalaya, Banaras Hindu University. I welcome you once again in this 12-week course titled History of Science and Technology in Ancient India from Harappan Civilization to 7th century CE. And today we are going to discuss Module 9 and Lecture 5. The title of Module 9 is Mathematics and Astronomy in Ancient India, and the title of Lecture 5 is Mathematics and Astronomy in Jain Literature. In our last lecture, we have discussed mathematics and astronomy in Buddhist literature, and now we are going to discuss mathematics and astronomy in the Jain literature. So, at first we discuss the learning objective of this particular topic, and the first learning objective is to understand the unique mathematical concept and methods developed by Jain scholar. The second learning objective is to study the Jain cosmology and its astronomical models, and the third learning objective is to know the philosophical and religious context behind the scientific thought. In this lecture, we are going to discuss mathematical disciplines, fundamental operations, mensuration, celestial bodies in Jain thought, Jain astronomical text, and measurement of time and space. Jainism, one of the most ancient philosophical tradition of India, made significant contribution to both mathematics and astronomy, driven by its unique cosmological and metaphysical worldview. Unlike the Vedic approach, which often linked astronomy with ritual, Jain astronomy developed independently to explain the eternal, cyclical and layered nature of the universe. Jain scholars demonstrated a remarkable understanding of mathematical concept, including the classification of numbers into numerable, innumerable and infinite. Detailed methods of calculation involving fractions, equations and permutations, and the early use of large numbers far beyond practical necessity. Work like the Sthananga Sutra, Surya Pragyapti and Chandra Pragyapti, also along with Mahavir's Ganita Sara Sangra, reflects a highly structured and logical approach to both mathematics and cosmology. Jain thinkers sought not only to measure the cosmos but also to align numerical precision with philosophical insight about time, space and karmic cycle. Their contributions played an essential role in the early development of Indian scientific thought and influenced later traditions across religious and scholarly boundaries. Scholars in Jain mathematics and astronomy. So, different scholars who gave their contribution to better understanding the philosophical, the mathematical and as well as the astronomical concept given by the Jain religion. Mahavir, a 9th century CE Jain mathematician, was the author of the Ganita Sara Sangra, an important mathematical treatise that made significant contribution to the field of arithmetic, algebra, geometry and combinatorics. His work is noted for presenting advanced methods that were ahead of his time, reflecting the high level of mathematical sophistication with the Jain scholarly tradition. Although not a Jain himself, Aryabhat, a 5th century CE mathematician and astronomer, had a profound influence on Jain scholar. His seminal work, the Aryabhatiya, particularly in astronomy, served as a foundational text that Jain intellectuals studied, adapted and expanded upon to suit their own cosmological and philosophical framework. Nemi Chandra is another name, a 10th century CE Jain scholar, authored the Trilokyasar, a significant work on Jain cosmology that described the structure of the universe using mathematical proportions to explain spatial and cosmological reason. His approach reflects the Jain emphasis on precision and cosmological modeling earlier. In the 6th century CE, Yati Varsabh composed the Tiloya Pannati, which presented Jain cosmology through high development numerical and spatial framework. He introduced complex concepts such as infinity division of time and space, showcasing a profound understanding of abstract mathematical ideas. In the 4th century BCE, Bhadrabahu, one of the earliest known Jain scholars, is believed to have laid the foundation for systematic cosmological and metaphysical classifications, thereby initiating a scholarly tradition that deeply influenced later Jain thinkers. The Sanang Sutra, 1st century BCE, a canonical Jain work, lists several mathematical disciplines that were studied at the time. These includes Sankhyayan, science of numbers. Second is Parikarma, basic operations, arithmetic. Third is Vyavahar, application or practical problems. Rashi, heaps of collections, possibly related to algebra. Rajju, geometry or mensuration. Kala Savarna, fractions. Yavat Tavat, equations, and it is also related to algebra. Varg, square or quadratic equations. Ghan, cube or cubic equations. Varga Varg, biquadratic equation. Vikalp, permutations and combinations. Now one by one we can explain these all points, which is Sankhyayan, science of numbers. This refers to the foundational study of numbers, including their properties, classification, for instance whether it is odd or even, prime or composite, and relationship. It often forms the basis for more advanced mathematical studies. Second is Parikarma, basic operations, arithmetic. This includes the fundamental operations like adding, subtraction, multiplication and division. In Indian mathematics, algorithms for these operations were sophisticated and often optimized for manual computation using place value system. Vyavahar, application or practical problem. This refers to applied mathematics using numerical methods to solve real world problem. Topic could include commerce, construction, land measurement and daily life calculations. Rasi, heaps or collection. While Rasi literally means heaps or aggregates, in mathematical context it is often related to the idea of quantities or algebraic expression involving unknowns, perhaps early conceptualization of variable and equations. Rajju, geometry or mensuration. The term Rajju means rope, hinting at the use of string or measuring the and constructing geometric shapes. This area included the study of shape, area and volumes, essentially the geometry and mensuration of figure. Kal Savarna, fractions. This topic deals with the understanding and manipulation of fractional number, including operations such as simplification, adding, subtraction and conversion to and from decimal or mixed number. Yavat Tavat equations algebra. This expression meaning as much as so much is associated with algebraic method. It involves forming and solving linear equations, often with unknown represented rhetorically, and show the beginning of symbolic algebra in India. Varg, square or quadratic equation. Varg means square. This section covers equations involving square of unknowns, such as the example is here, and methods for finding roots, often geometrically or through iterative approximation. Explanation about Ghan, cube or cubic equations. Ghan means cube. This area includes the solving of equations where the highest degree of the variable is the 3. Though solutions were less developed than quadratics, Indian mathematicians made progress with special case and approximation. Varga Varga, biquadratic equation. These involve equations of the truth fourth degree. The exploration of such high order equations shows the depth of ancient Indian algebraic thinking, though general solutions were not yet fully developed. Vikalp, permutation and combination. Vikalp refers to the various way things can be arranged or chosen. This early study of combinatorics include counting methods for different arrangement, permutation and selection, combination, often in poetic or philosophical contexts such as prosody or cosmological enumeration. Jain mathematicians in particular used such method to describe the vast cosmological possibilities, demonstrating sophisticated combinatorial thinking centuries before similar development in the West. The Jain theory of numbers reflects a profound interest in the enumeration and conceptualization of extremely large number. Jain scholar through the idea of Sri Prahelika proposed numbers as large as 84 lakh raised to the power of 28. Their numerical system employ the term sthan to denote decimal place, and beyond the unit of thousand, sahasra. They use an ascending order of terms such as 10,000, hundred of thousands, koti, crore, tens and hundreds of koti, and even koti of koti. Interestingly, in the Jain system, the number 1 is not regarded as a true number. It is said, eko gana sankhya na upeti. Furthermore, numbers are classified based on parity into oj, odd and yugma, even similar to classification found in the Brahman system. Jain literature divided the whole range of numbers into 3 main categories: Sankhya, numerable; Asankhya, innumerable; and Anant, infinite. Each of these groups is further divided into 3 levels, which is lowest, intermediate and highest. reflecting a detailed and layered understanding of magnitude. The innumerable group includes classification like nearly innumerable, truly innumerable, and innumerably innumerable. Similarly, the infinite group consists of nearly infinite, truly infinite, and infinitely infinite. This structure gradation demonstrates the Jain attempt to conceptualize and differentiate between various scale of enormity. An illustrative example from Jain text, particularly the Ayogadarva Sutra, explain how they comprehended the highest numerable number. It involves counting mustard seed one by one to fill a trough as vast as Jambu Dweep, a continent described in Jain cosmology with a diameter of 100,000 yojan and a circumference of 316,227 yojan, along with specific measures like gravity, dhanu, and angul. Even after such an enormous counting exercise, the number reached would still fall short of the highest numerable. The text emphasizes that this vast enumeration served only to approach an understanding of the first group. Higher group exceeds such effort by orders of magnitude. Thus, the Jain theory of numbers is not only mathematically rich but also metaphysically symbolic, blending cosmology, logic, and philosophy in its unique numerical framework. Fundamental operations and factors. The Jain mathematician made significant contribution to fundamental operation and geometry. Umaswati documented two main methods of multiplication and division. The first was the ordinary method, similar to what is commonly used today, while the second was a more efficient method involving successive division by factors. The second approach later appeared in the work of Brahmagupta and others. Sridhar in his Trisatika expanded this idea further. Jain are notable for their use of large numbers and complex arithmetic operation. A unique aspect of their mathematics was their frequent use of approximation when dealing with mixed numbers, specifically when the fraction part of a number was less than 1 by 2, it was designated. If more than 1 by 2, it was approximated to the next whole number. For example, instead of 315,089.216079, the big number is mentioned here, they would simply write 315089. They do not write the number, the another number beside the decimal. To indicate such rounding terms like kinchid visheshadhika, a little more, and kinchid visheshona, a little less, were used. So, with this description we can understand the idea to present any number system is very significant and it is very scientifically described by the Jain scholars in his or in their literature. The big numbers, how to express the big number in a short way, in a very precise way, and how to conclude these all number system in very scientific pattern in a very precise way, that is mentioned by the Jain scholars in different texts. Now, the rules related to the mensuration, what we found from the Jain text. In terms of geometry, the Jain term for the discipline was Rajju. closely aligned with the Vedic solar tradition. Their text contains many geometrical terms such as vrit, circle, vyasadhar, vyasardh, semi diameter, dhanurjya, arc, chaturashcha, square, triyashcha, triangle, ghan, solid, parimandal, ellipse, and ghan chaturashcha, cube. Umaswati in his Tatvarth-Digam Sutra Bhasya and Jambudvip Samdash recorded several formulae concerning the mensuration of circle and arc. Umaswati recorded a number of formulas concerning the mensuration of the circle in his Tatvarth-Digam Sutra Bhasya. These formula are: for a circle of diameter d, circumference p and area a. We can explain it with the help of another example what I am going to mention in this slide, that is, here p is equal to root 10 and d, a is equal to 1 by 2 PD, and this PD means product of the circumference and diameter. N number, another example related to the Jain mathematics. N number, if n is a highest number, then n group may be represented like this: n plus 1, n plus 1 square minus 1. You should fix it in a bracket. Next is n plus 1 square dot n plus 1 to the power 4 minus 1. Again n plus 1, 4, like n plus 1, 8 minus 1, n plus 1, 8, n plus 1, 16, n plus 1, 16, n plus 1, 32 minus 1. So, this is the way what I already said. If n is the highest number, then n group may be represented like this. Now, moving forward, in Jain mathematics, the concept of permutation and combination referred to the vikalp played a significant role in both mathematical reasoning and cosmological classification. Jain scholars, particularly Mahavir in his 9th century treatise Ganit Sara Sangrah, developed clear rules for calculating combinations which closely resemble the modern formula. This allowed them to determine the number of ways to chosen or arrange elements from a given set, whether for logical enumeration or for describing metaphysical structure. For example, to calculate how many ways three types of karmic particles could combine in group of 2, Jain mathematician would compute the number of combination. These results could then be applied in explaining how a soul might interact with different form of karma. The use of such combinatorial methods highlights the advanced level of abstraction in Jain thought, extending even to the classification of infinite sets and division of time and space. The explanation of the rule. First one, another rule is also explained by the Buddhist mathematician, but here I am going to show you with the slide. You just see the total number of permutation of r things taken all at a time is equal to 1.2 . Second is the total number of permutation having a particular thing A R for its initial digit. Third is the total number of permutation in which will be next to AR into R minus 1 by R minus 1 is equal to R minus 2. Proceeding in this way, different permutation of things can be found out. So, these particular formulas related to the permutation of particular method. Now, Jain cosmology. Jain cosmology divided the universe lok into three broad regions: the upper world, Udharva lok, inhabited by celestial being; the middle world, Madhya lok, where humans, animals and planets live; and the lower world, Adholok, which consists of various levels of hell. The cosmos is considered uncreated and eternal, and it is visualized in a symbolic anthropomorphic form resembling a standing human Lokapurush. The middle world includes Jambudweep, the central continent where Bharat Kshetra, India is located. Jain texts provide intricate details of the continent, ocean, mountain and the movement of the heavenly bodies within this framework. Time cycle and Kala Chakra. The Jain concept of time is cyclical, infinite and divided into two main cycles: Utsarpini, progressive, and Avasarpini, regressive, each consisting of 6 unequal epoch era. These era range from times of immense happiness and long lifespan to periods of suffering and moral decline. Time is measured with incredible precision from a samay, the smallest unit almost infinitesimal, or unimaginably large units like Palupama and Sangoropama. This extensive granularity in temporal measurement reveals the Jain focus on cosmic and spiritual chronology. Celestial bodies in Jain thought. Jain text categorized celestial being Jyotish into planet, star and other luminous bodies. Each heavenly body is considered a conscious being bound by karmic particles. Descriptions include the sun, Surya, moon, Chandrama and planetary deities. Although these are not worshipped, instead their movement and characteristics are detailed with observational accuracy. Jain cosmology includes calculation of the size and distance of these bodies, reflecting a deep engagement with the structure of the cosmos. Measurement of time and space. Jain have developed a complex system of measuring time and space. Time units range from samay, instant, to Uttasarpini and Avasarpini cycles. Space is measured in terms of angul, dand and rajju. A rajju is a vast distance unit representing the enormous scale of the Jain universe. These systems were not only philosophical but also aimed at organizing spiritual progress and karmic calculation. Jain astronomical texts. Several Jain texts deal extensively with astronomy and cosmology. Tiloya Pannati by Yati Vrishabha describe the structure of the universe with mathematical precision. Trilokasar by Acharya Nemi Chandra elaborates on the three worlds in details. Jambudeep Samasa explain the geography of the middle world. These texts contains diagrams, numerical data and systematic approach to cosmography, often parallelly of predating similar efforts in other tradition. Legacy and influence. Jain contributions to astronomy influenced mathematical and cosmological debates in ancient and medieval India. Their detailed cosmographical chart, precise time cycle and non-theistic interpretation provide an alternative model of the universe that continue to be studied for its originality. Jain cosmology also impacted temple architecture and iconography, where cosmic diagrams were incorporated into sacred art and ritual space. So, on the basis of this explanation, the intellectual tradition of Buddhism and Jainism offer profound contribution to the history of mathematics and astronomy in ancient India. Far beyond their spiritual doctrine, these traditions cultivated sophisticated system of logic, numerical classification, cosmological modeling and symbolic reasoning. Buddhist scholar applied mathematics to express concepts such as impermanence, emptiness and the vastness of cosmic cycle, often integrating logical structure into epistemology and meditation. Jain thinkers, with their remarkable precision in handling large numbers, infinity and spiritual dimension, developed detailed mathematical and astronomical framework that reflected their metaphysical view on a structured eternal universe. Both traditions demonstrate how spiritual inquiry and rational analysis can coexist, using mathematics not merely as a tool for calculation, but as a means of expressing and understanding deeper truth about existence, time and the cosmos. Together, Buddhist and Jain contribution represent a unique and valuable chapter in the global heritage of mathematical and astronomical thought. So, we can say that on the basis of mind, body and cosmic relationship among these three categories, the mathematical and astronomical concepts were developed and evolved during the time, and the use of that particular things is still ongoing in the modern era, and these thinking, the idea, the ideology is the basic platform for the modern thinking of mathematics and astronomy. If you want to enhance your knowledge regarding this particular topic, you can consult these references. You can also consult Concise History of Science in India by S.N. Sen. That book is also very important for you. Thank you for your patient listening. Namaskar.